Hey everybody, this is a video to help you through a lesson for CPM book 1.1.4, again CPM book, and I'm not giving page numbers because again the ebook doesn't have the page numbers. Okay, so the 1.1.4, okay, it started back here, right, and sometimes we're going to do the stuff on those right after the lesson starts in class, sometimes not, sometimes we do some of the problems. That's going to be the case today. And then the homework's almost always going to be where it starts and it says review and preview. And you can see right before the 1.1.4 there were some review and preview problems from 1.1.3. So now you can get used to that's going to be the case all the time. Let's shift this over so you can see the page of problems, and you can see the page that I've already filled out a heading for good old one of my favorite students, Albert Einstein. All right, and you'll notice in the heading when we're working out of the book, I also included the lesson number and the problems. That's a good thing to start doing. It's kind of a funky way the way they number the problems. You can't just say the problems 1 through 15 or 7 through 20. They have weird problem numbers. So let's just get used to using that and make sure you're labeling your problems, okay? You want to be able to find out, well, when we're going over it, where your answer is quickly, and then find out if you're right or wrong so you can fix it and learn from it if you made a mistake. Okay, so this first one has this big table, and the table is from this city, Urbana, Illinois, and it looks like it's showing different years, 1990 through 99, 2000, 2009. And then average temperatures, right? And this is in degrees Fahrenheit, right? So those look pretty low. Must be the average low temperature or something in the winter. I don't know. I think that's got to be wrong. No place in Illinois is going to have average temperature of 29 or 23 for this year. Anyway, what you want to do now is create a question that can be answered by using all of the data. Okay, so you want to look at all the data, and that's how you're going to find your answer. And sometimes you do something to it. I want you to, this is one of those things where I don't want to give you the question. I want you to think about it. But remember, it says using all the data. So you got all these years and all these temperatures in this place. What kind of questions could you come up with that would be able to be answered by using all those numbers? Okay. On B, it's saying create a question that could be answered using just some of the data. Okay, and again, sometimes you're going to use all of these numbers, or maybe you're using all the average temperatures that are above 30 or below 25. I don't know. You come up with a question that's only using some of the data. And then C, it says how can you organize the data to answer your questions? So different ways of organized. Right now, how is it organized? It looks like it's organized by year. 90, 91, 92, right? And it goes down to 99 and 2000. So right now, that's how it's organized. Could you organize it a different way? Think about that, and that should help you answer those questions. And remember, it says to write your answers in complete sentences. That's important. We need to learn how to write complete sentences. Right, we have to get rid of the tendency to talk in text speak is what we call it, right? LOL, yeah, BRB, all that kind of stuff. Yeah, so you come up with complete sentences for your answer. It's a good. It'll make you sound more mature, but more importantly, it'll give you good practice for when you go on in school to 7th and 8th grade and beyond. Okay. All right, so I'm going to switch over to 1-29. Use the histogram at the right to answer these questions. And this histogram looks kind of like a bar graph, but one of the things you'll notice about histogram is there's usually no gaps in between the bars. One leads to the other. And what's on the bottom is a range of data, is what they say. So from here on the bottom is everything from 0 to 5 is in that spot. Everything from 5 to 10 here, 10 to 15, and so on. So there's a range. It's not just one single point, it's a range. Everything between, if it's 0.2, it's here. If it's 4.3, it's here, right? If it's 5.5, it's going to be over here. Okay, so that's a range of data. The first question says, and this is about snowfall in Illinois, same town, between 1990 and 2009, same date range. Which range of snowfall measurements occurred most often? So 0 to 5, 5 to 10, okay? And it looks like that range of snowfall that happened the most often was over here. 6 years they got between 20 and 25. Does that make sense? Right? This is the tallest. That's the range between 20 and 25 inches of snow. And that happened 6 different years they got snowfall between 20 and 25 inches. So that's where our answer is going to be, right? And sometimes it's good to write the question and the answer. But what's even better is if you learn how to include the question in your answer. Example, which range of snowfall measurements occurred most often? I can write that question and then write the answer is between 20 and 25 inches. Or I can say between 1990 and 2009, in Urbana, Illinois, it snowed between 20 and 25 inches 6 times more than any other range. And hopefully you write neater than me. I'll work on it. All right, that's A. B, and that's using the question in my answer, right? I include the question in my sentence. Okay. Were there any years with unusually high or low snowfalls? Well, can we tell, based on this, if there were any years where unusually high or low? Well, it looks like one year there was less than 5 inches, right? And looks like 3 years there was more than 25. I'm saying that's, that might be the answer. Okay, and again, there's going to be separate. And so I'm going to say in 1 year there was less than 5 inches of snow. See, half the years had snowfall amounts above how many inches? So let me see, half the years. Are we just going to go straight to half here in the inches? No, we got to go 1 plus 5 is 6, plus 2 is 8, plus 3 is 11, plus 6 is 17, plus 3 is 20. So it's 20. I'm looking for 10. Okay, and really here these top two, 3 and 6 is 9. So that's almost half were over 20 inches. Okay, but we could definitely say more than half was over 15. I'm going to write both of those. Oh,
it's broken, is that?
Hold on. Okay, sorry about that. Interrupted. So almost half of the years had more than 20 inches of snow. Okay, and you could write, and more than half had more than 15 inches of snow. Okay, on to 130. Now we're talking about patterns. And this first pattern goes 2, then 7, 12, 17, 22. I notice one place is 2, 7, 2, 7, 2. Guessing it's going to be 7 again. But also a big thing to do is to subtract. Okay? What is the difference between 2 and 7? 5. What is the difference between 12 and 7? 5. What is the difference between 17 and 12? 5. Boom, boom, boom. So I think the next one's going to be 5 more than this. So you want to figure out what's 5 more than 22, and you want to get the next 4, and I think you guys can do that. This next one, a little bit tougher. 1, 4, 9, 16, 25. Those kids in my class who've been getting good at square roots might recognize these numbers. But there's another way to look at the pattern. Okay, what's the difference between 4 and 1? 4 minus 1 is 3, right? What's the difference between 9 and 4? 9 minus 4 is 5. Well, that's not the same number, is it? How about 16 and 9? That's 7, huh? And 25 and 16. That's 9. 3, 5, 7, 9. You see a pattern? That's one way of looking at it. Another way of looking at it is to think of squares. Hint, hint. And see, we got 1, then we got 1, then we got 2, then we got 3, then we got 5, then we got 8. This is crazy. What's the difference between 1 and 1? 1 minus 1 is 0. How about 2 and 1? 2 minus 1 is 1. How about 3 and 2? 3 and 2, 1. How about 5 and 3? 2. How about 8 and 5? 3. 0, 1, 1, 2, 3, 1, 1, 2, 3. Ooh. Hint, hint, hint. I'll let you play with that. That's a famous sequence there, those numbers there. Looks like that's bleeding through a little bit, so I'm going to start another piece of paper for this one. Okay, 1-31. We're rounding. Okay, and it says, look at the math notes in the box in this lesson to remind you how to do the rounding. I look back, math notes, methods and meetings. Okay, and then you might look at your notes when I told you how I round. Remember? Underline the place value. Put these eyeballs over here with the arrow. Look to the right. Check to see if it's 5 or bigger than 5, right? Remember those steps? All right. Anyway, we're rounding to the nearest 100 here. 5, 2, 9, 4, 6. And if I read this number, I say 5,200. So the 2's in the hundreds place. Look to the right, decide if that 2 is going to stay or if it's going to get bigger. Okay, on B, we're rounding to the nearest 1,000. And when I read that number, I say 45,000. I said 5,000. The 5 is in the thousands place. 469 and 23 hundredths. So for C, now we're going to the hundredths place. 7,526 and 442 thousandths. Remember, I have you guys put the .ths. Is everything to the right of the decimal ends in THS, and it helps you because that first spot is a tenth spot, second spot is a hundredths, so that 4 is in the hundredths. And the last one, thousandths place. 492 and 3,069 ten thousandths. The thousandths place is actually the third spot, though. So look to the right, see if that 6 stays the same or gets bigger. Those are only the choices. All right, last one, 1-32. You're looking at this cool graph here. Okay, and the graph is showing how far Ben is away from home. All right, so here he's at home. Maybe he goes outside, takes the garbage out, goes gets the cat, right at night, whatever. But here it's starting at 7 o'clock. He's leaving home. He's getting farther and farther away. Then he stays the same distance for a while, 2 miles. for a little while. Then he goes farther and farther away. Now he's 4 miles away from home from, looks like about 9 o'clock all the way till, I don't know, what's that, 2:30 or something? And then all of a sudden he starts getting closer to home till at 3 o'clock he looks like he's home again. Okay, so here's a good question. What's going on between 7 and 8? There's 7, that's 8. And what do you think Ben was doing between 9 a.m. and 2:30? Okay, and last one, what time did Ben leave to return to his starting point? Okay, I'm going to let you look at that and answer those questions yourself because I want to see what you think when you look at that graph. And again, this is how far he's away from home, and this is the different times, 7 a.m., 8, 9, all the way to 3. Okay, all right, good luck, everybody. I'll make another video to go over the answers.